All right, everybody. Why don't we get started, and we'll go from there. So my name is Rich Smigliani from Visible Edge, and you're here attending a seminar on flexible modeling, and this is part of a webinar series that Visible Edge and 3HDI are running collaboratively. So this is our session for today. We're going to be running future ones. For example, there's going to be one in a few weeks regarding Creo layout. But why don't we get started? So my name is Rich Smigliani. I'm the VP of Engineering Services at Visible Edge. Okay. Here's an agenda. So first off, just a brief introduction to Visible Edge, who we are, some information about our partnership with 3HDI, and then really the focus here is to really show you flexible modeling in conjunction with Creo 2, and then some Q&A. So I guess what I ask is kind of hold off your questions, or if you're going to ask questions, just use the chat function to either everyone or Greg Hamill to post your questions, and then we'll answer as many as we possibly can at the end of the demo. If there are any questions after the webinar is over, feel free to email myself, Rich Smigliani, or Rob Romanowski, and there's our email addresses right there. Okay. So Visible Edge, who are we? Basically, we're a full-service engineering design solutions provider, privately held company. Our territory is North America, and we've been in business for actually 23 years. Do business with quite a few companies. We've had a long-standing relationship with PTC. We've been a reseller for 18-plus years, so we've been in the ecosystem for quite a while. We're also a state-licensed post-secondary education institution as well, so we basically teach Creo and pro-engineer-related curriculums. Our services kind of span the gamut from consulting. We sell the software, obviously. We're a training center. Support agreements. We provide contracting, maintenance, hardware. So we're essentially like a turnkey solution with PTC products, and we service a whole wide variety of verticals, commercial products, all the way to aerospace products as well. So, okay. So we are currently an agent reseller in 3HDI. So we're basically partners with 3HDI. And really on two fronts. One is regarding selling software. We have a reseller agent relationship for the PTC software products as well as training services. And then also we collaborate on quite a few things. This webinar is an example of that, but we collaborate on marketing events as well as technical engagements such as AE work, consulting, and mentoring. So we work together quite a bit to service our PTC customers. Okay, so enough of the sales spiel. So what you're here to talk about, what you're here to learn about is Creo 2 with flexible modeling. So the idea here is we're going to teach you how to be able to work with models that normally would be difficult to work with. Okay, and really we're going to talk about really three key situations. One is making 11th hour changes to actually a parametric native Pro-E model, a Creo model. So we'll discuss that situation first. We'll also discuss how to work with data that does not come in from ProEngineer or Creo. So this is data that's been imported from other CAD systems, such as SolidWorks or Inventor or STEP out. And then also, say you're an analyst, or you have to take a really ugly model and prepare it for doing some type of analysis or some type of rapid prototyping. Now, I'm focusing on a non-native CAD data, but it could also be a native ProEngineer model. So really how to take an ugly Pro-E model and kind of remove features to groom it or doing some subsequent analysis, for example. That's the game plan. That's the game plan for today. So let's get right into the demonstration. Okay. So what you see on the screen here is my first example. So this is an example of really kind of an ugly parametric Creo 2 model. And what I mean by ugly is I'll show you in just a second. So let's put on my design engineering hat. And it's late Friday, and I'm tasked to make some time changes to this part and get this design out by the time the weekend rolls around. Problem is, I'm starting to take a look at this model, and I'm going in and actually editing one of the features, and I'm noticing that this model was created in a very messy, ugly way. So, you know, the battle with sometimes modeling parametric models is you sort of have to figure out how the model was built in order to determine how you actually make modifications to it. So this is a situation where I have to get the archaeologist involved to help me kind of figure out the history of this model in order to make changes in a parametric fashion. So what I'm going to do is I'm going to utilize flexible modeling to make changes to this model by really kind of pushing and pulling geometry to get the desired result. So first thing I want to do is I want to go in here, I want to modify this rib geometry up here. So I'm going to activate flexible modeling, and I'm going to basically just start grabbing geometry. So really what I'm doing is I'm grabbing these two really wall surfaces right here, and just really kind of using the mouse button to pick both of them. And then I'm executing some flexible modeling functionality. So I'm going to use an option, this example, a new option called Move with Dragger. And a coordinate system appears, and I'm just really going to take this wall here and just kind of drag it down by, like, say, 8 degrees. So I'm making a pretty radical change here to this model. So that's one of the changes I need to make. Second thing I want to do is I want to take this wall and kind of thicken it up a little bit by also performing the move command. And I want to move it normal to this surface right here. I'm just going to drag this out by some distance. In this example, it's going to be 1/8 of an inch. See, the idea is I really don't care how the model was originally built. I'm just operating purely on geometry, okay? Notice in the model tree, you see a couple of different move features here. So these are flexible modeling related features, and if I go in here and I actually edit them, these are features that I later on could change as need be. So, that's the idea. Again, I don't care how this model was originally made. In this example, it's parametric, but it's really ugly, very difficult to change it to parametric fashion, so I'm changing it really in a non-parametric fashion. Let me show you some more examples. I want to make this hole in the middle smaller. So I'm just going to pick on this geometry option called Modify Analytic, and I'm just going to drag this to another value. In this example, I'll go with 1 here to make that change. That's another example of doing that. Now, what I also would like to do is I want to modify. I want to move this, I want to kind of make this thing a little bit shorter. I want to basically pull up these two surfaces here. So I'm going to grab these two surfaces right here, and I'm going to use an option called Move by Dimension. And what that will let me do is in a really almost like a parametric fashion, it'll let me define a dimension that I could use to determine how far these two walls get moved up. So I'm actually dragging that up by a particular value here. So I'm just going to put in a value, in this example, 0.625. Okay, so I've made some, I've done it in a very simple fashion, but I've made some, pretty decent changes to that particular model without even worrying about how it was created in the first place. Okay, a couple other things that you might need to do is, one is I want to remove some geometry easily. I'm just going to take this, in this example, I want to grab this cut geometry, so I'm recognizing it as a cut, and I'm going to use a function called remove to basically just get rid of that geometry. That cut is actually gone. I also would like to get rid of these two side tabs. I'm going to pick one of the surfaces and one of the tabs and utilize an option called box with secondary, which kind of recognizes all of that geometry, and then I'm just going to simply remove that. Okay, so I basically wipe those surfaces or wipe those solid features out. Okay, next up is I'd like to modify some of the radiuses and some of the rounds. I'm going to grab one of these rounds. And what I would like to do is, using an option called Geometry Rounds, I'm grabbing all the other rounds in the model that have the same radius. So in this example, it grabbed like 4 of these. And then I like to edit the round to really change that geometry. So it automatically recognized all the rounds with the same radius and allowed me to make a change to that. So those are some changes that I made to this particular model. And again, if you look at the model tree, you're going to see all these features that I created here, which I could actually delete or remove. Or so if I want to put this back to where it was before, I could simply just go back in time, and now I'm back to where it was before. Okay, so these are features that I could extract or use or reuse anytime that I want. That's my first example. Okay, next up is importing geometry. So I'm going to bring in actually a SolidWorks model. So I'm just simply going to do a file open, and I'm going to open up a SolidWorks assembly. And this happens to be a sheet metal, power supply cabinet. So I'm going to open this up. So this is the geometry that I'm looking at. It's really a couple of sheet metal parts that originally were SolidWorks files. So the idea here is, I'm working in Creo. I need to make these modifications in Creo. Problem is, in the past, when you bring in dumb geometry, there's really not much you can do with it. When you import geometry from the CAD system, you don't have a lot of flexibility in terms of the changes that you can make. But with flexible modeling, I actually do. So I'm going to make some changes here. So first up is I'd like to make sure that this top cover sits on top of the bottom cover. So I'm just going to go into Pro Engineer, go into Edit Definition, because this has actually been assembled. So I just want to make sure that a couple things. One is this surface right here of the, I'm just going to kind of click here and grab this surface right here, is physically mated to this other surface. So those are basically sitting on top of each other. That's going to be important because I'm going to be raising the height of each one of these to make some changes. So the first thing I'm going to do is grab this first cover by itself and open up in a separate window. And I'm going to make some pretty decent changes to this. So the first thing I want to do is I want to delete these tabs right here. Again, I'm using flexible modeling. I'm just grabbing geometry. I'm using the geometry rules to grab all the other ones that have the same radius. So in this example, is actually 4 of these geometry for these tabs. I'm going to physically just remove those using a remove feature. And you'll be seeing removal also a lot more during the third example that I'm going to bring up in a second. Same thing on the bottom here. I'm going to grab all this geometry, all the same radius as all 4 of them. I'm going to do a remove. So that basically blew those away. Now what I'd like to do is I want to raise the height of this sheet metal cover. Okay. I actually just closed that window accidentally. Excuse me. I want to make this higher. So I'm going to use a function called move. So I'm going to grab the surfaces that I physically want to move. So I'm kind of pulling them up is really what I'm doing. I'm going to use an option called move by dimension. And I'm going to set up a dimension that's going to tell me what that height is going to be. So I'm going to basically choose this bottom surface right here, and I'm going to grab this surface right here. And that gives me a height dimension. I want to raise that from 0.08 to 0.10. So now I've added some height to that particular geometry. I've raised the height of that sheet metal part pretty easily. Okay, if you look at the model tree and you perform an edit, you'll see that there's actually a physical dimension. So later on, you can go in there and you can change that. So I've sort of taken something that wasn't parametric and I gave it some parametric capability. So later on, so you can actually show that dimension on a drawing, for example, and make all other kinds of changes. Next thing I'd like to do is I want to remove these 3 slots on the side. So I'm going to grab a surface of each one of them and recognize them as a cut in flexible modeling. So I'm just grabbing each one of them one at a time, recognizing them as a cut, and then I'm going to just physically remove them. So we'll get rid of that. We'll get rid of that geometry. Next thing I want to do is I have this pattern of slots on the top. I actually want to change that. So I'm going to simply just grab one of the surfaces of the first slot, recognize it as a cut, and then click on pattern recognition. So this automatically recognizes this as a pattern. In this example, it's a pattern of 19 of these slots for the space 0.005 apart. I want to be able to change that. So I'm going to edit that pattern, and instead of 19, I'm just going to say I want 8 of them, and I want the spacing to be, for now, 0.10. Okay, then we'll accept that. So I basically have changed that pattern slots. Again, remember, this was not a native model to begin with. This is a model that I actually imported into the system. So those are the changes that I've made to the top, I'll call it the top cover. If I go back into the assembly and I regenerate the assembly, okay, notice that we have a little gap here between the top and the bottom. That's because I changed the height of the one component, but I haven't changed anything on the second component. That's what I'm going to do right now. Let's bring up that second component, perform an open here, and then perform some very similar operations to make that fit with the other cover. So we're going to go in, again, flexible modeling. I'm going to get rid of these tabs on this as well. Going to do a remove. Now there's actually 4 of them as well, which fits onto the other part. So we're going to remove those. And same thing on the bottom side of this. Geometry rules to grab them all, do a remove. All right, so next thing I'm going to do is I'm going to raise the height of these walls one at a time to basically have it match up to the other component. So very similar situation, I'm going to use the move function. In this example, I'm grabbing the top of this wall, the bottom of this wall, the top of this little, I'll call it flange here, and the top of this flange right here, because I want them all to move up together. And I'm going to perform a move by dimension, just like I did before. And I want the dimension of the move to be from here to the bottom of this tab right here. So what you'll see is that 0.08 dimension appears just like before. I'm going to change that to 0.1. And notice that all that geometry physically moves up. Same thing on these other two walls or these other two flanges. Very quickly here, I'm going to grab the corresponding sets of surfaces here, this one and this one. Now, I could have done this all at once. I like to do it piecemeal just to have it, just so it's easy later on to make future changes. So those are the three surfaces I physically want to move. So again, move with dimension. And I want to, again, dimension from the bottom to this surface right here. There's our 0.08 again. This is going to be 0.1. Again, we raise the height of that. Next up is this last little tab here. Pick this geometry. This surface, and this little piece of the wall here, or flange. That surface, and again, move by dimension, same fashion. I want it to go from dimension from here to here. And again, this will be 0.1. Okay, so I've made some pretty radical changes to this. Now notice what's happening here with this wall here. See what it did is it extended the wall, and there's a little piece of a radius that didn't get extended or I didn't want to extend. I'm going to close this thing up right now by performing a couple more move operations. So I'm going to perform a move like I did before. This move is pretty powerful. I'm going to perform a move like I did before. I'm going to grab this wall surface here. I'm going to perform a move by dimension just like before. Okay. Now in this example, what I'd like to do is when I dimension it, I want to dimension it from this wall surface right here to this surface right here. So I want that wall to get extended until this dimension is basically 0, which makes it flush. That extends right to that very edge, right to that very wall edge right there. Same thing on the other side, performing another move here. I'm just using really kind of the same functions. It's really powerful. I don't really have to learn, as far as the learning curve goes here. There's not really too much that you have to learn. There's only about, a few different powerful tools that you can use here. So again, same situation here. I want to go from this surface to this surface. Am I setting up my dimensions here? Actually, let me do that one more time here. Jump the gun. This is the surface I want to move. And I want to set up a dimension from this surface right here to this surface right here. Oops. Click, little click happy there. Make that 0, just like before. And now that's closed up as well. So I'm making some pretty radical changes to this. Let's go back and take a look at the assembly and see what we're looking at. I'll regenerate that. So again, these are all matching up, obviously, because I made it higher, so that they do match up. A couple more quick changes I want to make. I'm going to go back to that panel that I was working with before, this second one here. I'd like to move up these cuts. So that obviously the sheet metal, the box is higher, so I want to move these cuts up a little bit. So I'm going to use, again, another move function, and I'm going to just grab these cuts. It's just involving picking the surface, recognizing it as a cut. And I'm just going to do this for all these surfaces right here pretty quick. Recognizing this as a cut. Hey, we'll grab all these guys. It won't take too long here. This is a cut. Again, I'm just using, the software is recognizing the fact that the cut, it sees that it's part of some cut geometry. So it's recognized it appropriately. So I'm grabbing all of these cuts here all in one shot. Now I could have done this one at a time if I want a little bit more flexibility, but I'm going to do them kind of all at once. So these are all cuts. I'm going to perform, again, that move by dimension. Okay, and I want the dimension to be defined from the bottom of the box right here to this surface right here. So now I got this dimension that I can actually change. Now right now it's 0.001. I'm going to make it 0.03, so I'm raising it the same amount that I raised the height of the entire box. If I click OK, now I've moved all those up by that dimension right there. All right, so again, I'm making some pretty radical changes to this. A couple other things I want to do real quickly. I also want to utilize pattern recognition to manipulate this pattern of slots here on this side. So the secret is you pick the first slot, recognize it as a cut, and then if I click pattern recognition, you'll see the pattern of, really in this example, the top and bottom slot's original pattern. and I could edit this pattern like I did before, but in this example, I'm just going to kind of willy-nilly turn off the members that I don't want, and I can actually turn on the ones I do want. In this example, I'll just shut some of these off. Very similar to a native pattern within Creo. So now I've selectively turned off and on some of those members of the pattern, again, from a model that came in from another CAD system. So I made some pretty, again, I made some pretty wild changes to a model that's not native, and really, was able to take this geometry and work with it going forward, make a drawing, et cetera, make the appropriate design changes. That's the key. All right, so that's example number 2. Example number 3 is grooming a model for performing either FEA or some sort of analysis, whether it's creating a rapid prototype, etc. So I'll go in and bring up my 3rd example. And this example is going to be a STEP file. So I'm actually going to be importing in a STEP file. So again, in the past, once you imported a STEP file, it was really dumb and you really couldn't do much with it. Now you can actually manipulate it. So I'm going to open up this housing STEP file. Okay, so this is basically this is just an example of a housing. So this is, again, non-native geometry, comes in the form of a STEP file. And my job is to perform, for example, some FEA analysis of this. So usually when you're performing analysis of this, you have to take the model and eliminate some features that aren't important for analysis. So another word for that is defeaturing it. So basically getting rid of the stuff that you don't need for the analysis. So here I'm going to start with a few things. One is I really don't care about this little 555 stamp. So I'm going to go into flexible modeling and use some of the same tools you've already seen. I'm going to recognize each one of these 5s as a cut. And I'm just going to use that remove function to get rid of it. Okay, so that's gone. What I also like to do is I want to remove this inside round here. So if I grab a piece of this round and I use an option called round with secondary, it automatically grabs all the connected rounds to it. This is like one big round here. And again, this is another thing I can selectively remove. And again, remember, anything I remove I can get back again just by either deleting or suppressing the feature. All right, so next thing I want to do is I want to remove this other outside round. So I'm just going to select this geometry like I did before, use the same function. I'm going to grab this. I'm going to do a round with secondary, which grabs the entire outside, perform another remove. All right, so the model is getting simpler for me. Now, a couple other things I want to do is I want to be able to have some dimensions for my analysis that I can play with. So if the analysis gives me invalid results and I got to make geometric changes, I want to make the model kind of semi-parametric like I did with the original one, like the other models that I showed you. So I have a dimension that I can change later on and maybe run subsequent analysis. So I'd like to have the ability to change this inside radius right here. So instead of just removing it, I want to be able to change it. So I'm going to grab this, recognize it again as a round with secondary, all right? And then there's an option here called Edit Round. And what you'll see is the current value of that round. I can say, you know what, I want to make that 0.08. So I'm changing that value. So that's actually a dimension later on. I could just use the parametric nature and just edit that dimension later on and make it whatever I want. All right, so that's important. So I've dumbed down the model. So far, I've dumbed down the model by getting rid of features, and I've also added some intelligence to the model, in this example, by changing the radius. Now, same thing with some of these other features. If I wanted to, maybe I wanted to play with this hole and make this bigger or smaller based on the result of the analysis. I could pick the hole, I can use that modify analytic function, and I could drag this and put whatever value I want. And again, that's something that I could go in there and I could change after the fact, anytime that I see fit. Okay, what I'd like to do next is I want to remove this tab geometry along the top of this. I want to grab all of this geometry and just remove this from the model. So maybe one of my situations or one of my analysis situations I have to run is I want to run this with and without certain tabs or certain bosses. So here I'm just going to grab all the geometry for this specific, I'll call it tab or boss here. So I'm grabbing everything here, inside and out. including the rounds. You can see here. So there's the outside of it, and I'll also grab, I don't want the round geometry either, so I'm just going to physically grab that. So here, sometimes you need to select the geometry appropriately, like in this case. So everything that I want to just physically remove. So I'm grabbing all of that geometry. I'm going to use that remove command, and that physically just extracted all that geometry from the model. Physically get rid of it as if it wasn't even there to begin with. All right. I want to do the same thing with this cut, this little kind of pocket, and this other cut on the other side. So I want to do the same thing with that to defeat it. So here I'm going to get some help from this cut option to recognize that, and then I'm going to also use the cut option to recognize this, and then I'm going to go in and grab the remainder of the geometry. In this example, there's rounds here, there's rounds on the outside. I don't want that edge, I want the round. I'll zoom in on that. And there's also rounds on the other side, which I'll get rid of as well. So once I've grabbed all of that, I'm just going to perform a remove, which basically gets rid of all that. Okay, so I'm just extracting all the geometry that might not be necessary for me for running an analysis. And again, if you look at the model tree, all these features are captured for permanent reference, and you can grab them and use them anytime you want. Just like with the other models, like I mentioned, I made some design, I'll call them design changes. I made some things parametric. I can do the same thing here. For example, maybe one of my analysis scenarios is what if I make this a little higher? I can perform a move command to make this a little higher. I'm just physically kind of dragging that up a little bit. Okay, so the idea here is I took a model, and for FEA, I removed some geometry, and I put some smarts into some of the geometry for performing whatever analysis I need to perform. So those are the three scenarios that I brought up here. I'm going to go back to my slide presentation here, but those are the three key scenarios that flexible modeling can really attack. It's really the ability to take a really ugly Pro-E model that was made in Pro-E or Creo and work with it. So you can actually use data that maybe you can use data that was made 10, 15 years ago that wasn't made in a very good fashion and change it. And then working with, a key thing is working with non-native CAD data. So the idea is I brought in something in SolidWorks. Same thing applies for Inventor. I also brought in a STEP file as well. So the idea is bringing in a model that was originally dumb and building some intelligence into it and be able to work with it, like I did with the sheet metal cover and the third component as well. And then another situation, again, is working with data that's pretty heavy, whether it's native CAD data or non-native CAD data, and be able to get rid of features and groom it for performing analysis or performing rapid prototyping or doing whatever you need. So, so those are really the three really key use cases for flexible modeling. Now, I'm running flexible modeling in conjunction with Creo 2. So with Creo 2, I'm starting with Creo Parametric, which is the parametric modeler, which is what used to be known for most people as Pro Engineer. But then I'm accessing within Creo Parametric, I'm accessing flexible modeling. So I'm taking advantage of all the parametric capability, and I'm using a sliver of direct modeling capability, which is called flexible modeling, to let me push and pull and manipulate things in a very non-parametric way. So that's pretty much all I have for my presentation. I guess the next part of this is what I'll do is I'll unmute Greg, who's fielding any questions that you may have, and we'll attack those right now. Okay, so just take me a second here. Okay, Greg.
Yes, I'm here.
Are you there?
I am, but I so far no questions, so everybody's mesmerized. I guess.
Is everyone sleeping, or they don't care, or so? Yeah, if there's any questions, please, if you can send them out right now or after the fact. If you have any questions regarding this presentation, feel free to contact myself, and I'll bring up that slide with the contact information again. Either myself or from Visible Edge is my email address, or Rob Romanowski for a lot of 3HDI customers that are on board here. Any other question? Any questions at all, Greg?
Yeah, there's actually one now. Can you reorder features?
Yes, you can. You can reorder features just like regular parametric features. The only time you can't reorder them is similar to ProE parent-child relationship, but you can't reorder a parent to come after the child. But they reorder in the same fashion. Anything else?
I don't have any further questions at this time.
Okay. Well, I guess we said we'll keep it to a half an hour, so I guess that's what we did. Again, I appreciate everybody's input, and I appreciate everyone's attendance at the webinar. And I hope this provides some good knowledge and really some powerful capabilities that you may want to take advantage of. And I see one question about how to resolve. Did you get that one, Greg?
I don't see it yet.
Okay.
Oh, no, I don't. I don't see it.
I have a question.
Yes.
Do you know what would happen if you apply shrinkage to those features?
To the sheet metal, to the flexible modeling features?
Yes.
It will allow you to apply it. I mean, there's a couple of types of shrinkage you can apply. One is based on dimensions, and the other one is just a pure shrink. But yes, you can apply them to both sets of features.
All right.
I
have another question. What happens after saving this and, say, sending it to a customer that doesn't have a seat of flexible modeling?
Yeah, they'll be able to open it up. They'll be able to look at the features, but they won't be able to manipulate them. Like they won't be able to go in there and edit definition, for example. But they'll be able to
change a dimension that's there.
They can edit dimensions, yes, but they won't be able to go in and say, edit definition, I want to pick a different surface, for example. Very similar to years ago, PPC, the sheet metal package used to be a separate package, but somebody who made something in sheet metal could send someone to a customer that didn't have it, and they could go in there and they could edit it, but they couldn't do anything drastic. So I have another question here, showing a common mistake that results in an error when using flexible modeling. I think I'm trying to think of an example. Sometimes what happens is this is sort of almost like playing with matches. Sometimes is you can really do some powerful things here, and sometimes what will happen is when people are pushing and pulling and clicking things, they may be pushing and pulling and clicking to make some changes to the model that it just can't regenerate, and just doing some things that it physically can't create the geometry. That's what I've seen quite a bit. A lot of times what I've seen quite a bit too is a lot of companies are almost, this is such powerful functionality that the companies that are using this are actually developing standards where you only can use it in a certain way, and you can only use it in certain situations, because you can really, people who are poor modelers to begin with, this just gives them another tool at their disposal to perform even poorer modeling. So a lot of times you do want to have some rules on how to use this, because this is really great, powerful stuff. So
I have one last question from our end. I know a competitor has a similar package, and their package allows you to assign dimensions to the current geometry as is, and then from there you can add shrinkage rather than assign a dimension and then move it. Is it possible, say, if you have a boss feature on a dumb solid, to assign actual manipulatable dimensions but leave the geometry where it is?
Yeah, you can. You remember the example where I was doing move by dimension, for example? Yeah. I could have just left the dimension as it was, and it would have been in the same spot. And then I could change it later on. Like when I made that wall 0.1, I could have left it at 0.08, which would have been its original dimension. So I could, so I can, so to answer your question, yes.
Okay, cool.
You can do that, absolutely. See, that's a good point, because a lot of times companies use this to just make a model, semi-parametric. Yeah. And that's how they would do that. So they would identify the dimensions that they want to be semi-parametric they can change later on without moving it and then doing that. So
extremely advantageable if you have a dumb solid that from a customer and you want to apply shrinkage to it without rebuilding the model. You can assign dimensions to the separate features.
Absolutely.
Dimensions.
Absolutely. Now I got another question regarding issues with modifying family table items. So these are features that you can add to a family table. Sometimes, again, the only issue might be with family table items is if say you're making I did like a modify analytic where I gave something a dimension like the hole or some feature. The issue can be, a lot of the issues I've seen are really regeneration issues. So if you put in something and you change the value, it changes to a dimension that causes the model to fail. That's really the main type of thing I've seen with this. These features are a little bit heavier than regular parametric features too, so from a performance standpoint, it's a touch slower when you're dealing with family tables. But in general, that's really the only things I can think of regarding limitations with instances and family tables. So, any other questions? I don't see any other ones here, but Greg, do you have any?
No, I see what you see, nothing more.
Okay. Okay. Well, I guess on that note, I guess we'll end this and let everyone go to lunch pretty soon. But again, thank you for attending, and I hope it was helpful. And have a great day.
Thanks,
Sure.
you too.